Again, I appreciate the invite. I'm not exactly sure how I got put on the same program with another couple of very high-powered rock stars, but I'm very grateful for the opportunity to speak with y'all today. Some of this we've already heard earlier, so I'll try to skip over what we've already heard from our previous speakers so that we don't have too much redundancy involved. But I'm going to focus more on what goes on inside the chicken house. I'm an extension guy, and most of my work is either with the industry or with farmers. From a commercial standpoint, I do work with a lot of county agents and their backyard clientele, a lot of homesteader type folks. So I kind of work both sides of the fence, but I probably had more over my career to do with the commercial side than I have the backyard side. And a lot of the data I want to talk about is related to, the commercial application and how the commercial industry can best take advantage of precision livestock farming. So we're going to look at the goals and the purpose, information perception on how we can use this information and how it is perceived, how we collect it, the obstacles to applying PLF technologies, and there are several of them, but we'll talk about those. Integrator and farmer concerns, because both of these folks have issues, have concerns with too much technology, and we'll talk about that here in a little bit. And then we'll look at some of the University of Tennessee field testing that we've done with an actual robot on a rail inside of commercial chicken houses and what worked and what didn't work. So again, application of precision agriculture approaches in the livestock and poultry industry, which is basically what I'm considering precision livestock farming, or what most everybody calls, PLF for short, just so that we kind of know what we're talking about. So it involves technologies that deal with automatic real-time monitoring. And real-time monitoring is a key, folks, in terms of what precision livestock farming can offer us, but also the behavior, the health, the environmental impact, and the production performance of those birds. And I'm going to talk about this a lot as I go through this presentation, but we, being the poultry industry, we are going to have to figure out whether we want to use precision livestock farming to look at animal welfare, or are we going to look at trying to improve production? Because the two things can be the same, but they are also very, very different strategies in how we approach this. So the purpose being, we want to be able to detect deviations at an early stage and improve animal health and welfare and efficiency of those birds, expecting an improvement in production sustainability, because nobody does something if they don't expect to get something in return. Yes, we want to see the animals happy, healthy, efficient, productive, but again, if we're going to look at PLF as a way to improve animal welfare, we need to focus on animal welfare. And then the gravy will be seeing an improvement in production sustainability. One of the goals of animal welfare, one of the goals of PLF is to improve our animal welfare. That's not the only goal of PLF. Again, we want to see, less problems with the environment. We want to see improved production. But one of the main goals, one of the things we focus on when we talk about PLF, or that we should focus on when we talk about PLF, is the improvement of animal welfare. Now, most PLF systems do monitor at least one or more factors. And they can send alerts to a phone. They can tell the grower that something is out of whack inside that chicken house. And that is good farm management. That helps that grower be a better producer. But it's not a total and complete welfare assessment of everything that is going on inside that house of chickens. So again, it begs the question, is PLF going to be aimed at increased production, or are we going to try to focus it more on animal welfare? And we have to make that decision. We need to make it pretty fast. Miriam's already talked about this to some degree. There are multiple ways to monitor and measure animal welfare. There are several different styles out there. Some look at more factors than others do. But again, these are the type things we're looking at whenever we want to start talking about animal welfare. How is it benefiting that bird? Not just in giving it everything that it needs, but also in giving it the things that it wants to make it a happy, healthy bird. Precision livestock farming is defined as management of livestock production using principles and technologies of process engineering. So it is high-tech stuff. Again, sometimes we don't think about farming as being something that is all that technologically advanced, but in today's world and in the world of the future when it comes to poultry production, that is going to be the case. And it's based on automatic data acquisition, access to that data, and how that data is processed. So data from diverse sources are collected through smart sensors. It's compiled to a central database somewhere. It's analyzed to create an automatic management system that, again, is based on real-time monitoring to control animal performance, animal health, and the welfare of those creatures. But again, we need to keep in mind that there is such a thing as too much data for the farmer to handle. It's got to be given to them in doses that they can accept, that they are willing to deal with, because if we overwhelm them with too much data, we're going to lose them. And it must be able to automatically manage a commercial poultry farm equipment based on the collected information. It needs to be able to talk to our chicken house. The chicken house has got a controller on it that turns the heat on and off, that turns the fans on and off, that monitors conditions inside the house. We need to use this PLF technology to better manage that chicken house environment. And to do that, it's going to have to be able to communicate with the equipment that we have inside the chicken house. Animal welfare is essential if we're going to address the consumer's demands today, because they want to know how these animals are taken care of, how the farmer is looking after those animals, making sure that they do have the correct temperature, the correct ventilation, feed and water when they want it, all the things that they need to be a happy and healthy animal. If we're going to be able to sustain the commercial poultry industry long term, we're going to have to be able to meet consumers' demands. And consumers' demands right now say they are interested in animal welfare. But assessing that welfare in a large poultry flock is a very difficult thing to do. We've got chicken houses today that are 66 feet wide, 600 feet long. They've got 40, 50,000 individual birds in each house. How do we assess the welfare of each one of those individual birds? This is a difficult thing to try to attack. And the ability to detect potential welfare risk and to control or minimize the impacts of those risks is very, very challenging when you've got 40 or 50,000 birds in a house. But developments in technology and modeling opening up new possibilities to do that. And that's where precision livestock farming can come in very valuable. PLF tools are going to allow data collection on conditions and animals, again, in real time. And it's that real time thing that is valuable to farmers and to the integrators that these farmers grow birds for. Sensor data can be analyzed to create automatic management systems based on real time information to control animal welfare, health, and performance of those birds. But again, the compatibility of those precision tools with the farm equipment that is already in the house, the controllers, the feeders, the drinkers, the fans, the lights, all of that is going to be critical. PLF tools can detect problems with animal welfare early, and that's going to be a benefit to farmers because it can help improve and accelerate their management decisions, how fast they react and what kind of reaction they do have, and reduce the economic losses if something does go wrong. Hartung and others in 2017 indicated that farmers, for the most part, using PLF systems, they did prefer integrated data compared to traditional management practices. But the high price of the technology was seen as a negative, and it's going to be a negative for individual farmers. If we are going to utilize this system, we're going to have to convince the poultry industry, the integrators, that this is valuable to them. We cannot convince the farmers because they alone are not going to be able to pay for the system, regardless of how much they would like to see that system on their farm. We're going to have to convince the industry, the integrators. And again, even though the price of the technology was seen as a negative, the technology itself was seen to impact higher profits. So again, the question, is PLF the path to better animal welfare, or is it going to be just another method that the industry wants to use to try to perhaps increase economic returns first, and then hope that animal welfare kind of piggybacks onto that and comes along? And it's a complicated system inside a chicken house. A lot of folks that do not understand poultry farming and how the system is set up have no comprehension of how this process actually works. But again, we've got all these animals inside a chicken house, and we have to be responsible for their physiological and behavioral response to the conditions we give them. And we need to give them the correct conditions. Now, PLF sensors can certainly help monitor that. And in some cases, in a sudden event that needs immediate attention, it can send a message to a farmer's cell phone and tell them, you need to get out there and take action right now to try to get the climate and the housing and the nutritional system back the way it needs to be. But this PLF technology can also use sensors to collect data that we can use in the future. Real-time data analysis and visualization of this technology can send feedback, can send early warning, can send management support to that grower and help that grower figure out, am I on target? Do I need to do something? Do I need to take action? Or am I good for the time being? Because again, the goal is to maintain the microclimate that those birds need, the housing they need, the nutritional setup that they have to have. Birds are going to perform very, very well these days. The geneticists have already figured out how to make them perform, but they'll only perform if we give them the right environment. So again, it is a complicated system to have to try to figure out and have to try to manage. Sensors are an example of how to do this, though. In some ways, some sensors have been around for quite some time because we've been able to monitor the temperature. We've been able to monitor the ammonia concentration inside the house, the air quality, the internal environment. And those things are valuable to growers. And the more we can high-tech this, the more value that grower is going to be able to get from that. But that's not the only thing that we can monitor. Not only can we monitor the air quality conditions inside the house, whether it's ammonia, CO2, humidity, temperature, sound is an important thing today. There was a time not very many years ago when microphones or cameras inside a chicken house was unheard of, was unthought of. Nobody wanted it. Nobody thought there was any advantage to that. But that is all changing today. It's changing rapidly because, again, sound levels, camera video can show us things that we were never able to track before. Feed intake measurements, growth prediction, thermal comfort of those birds, stress detection, feather pecking and laying hens, locomotion, which is a huge thing in the broiler industry, which is usually where I spend most of my time, assessing locomotion deficiency in those broilers, using GIS to evaluate the space use for laying hens, the study of hens' jumps between perches or off the perch onto the floor. What is the impact on keelbone damage? How the hen's use of pop holes and its effect on keelbone fractures. All of these things, was unheard of just a few short years ago. And taking the health status of that bird, trying to detect whether avian influenza is actually affecting that flock of chickens by measuring the temperature variations of those broilers early on in ways that we were not able to do before. The potential is there to do absolutely great things. We've just got to know how to monitor and measure that type of potential. Part of what is challenging from a PLF technology standpoint is that all of this technology has to be developed in a lab somewhere, but it has to be validated inside a chicken house. And those two things are totally different environments. The lab is completely different from inside the chicken house. But the technology that is developed in the lab has implementation that can add value in two different ways inside the chicken house for the farmer and for the birds. The technology in poultry production enhances production of those birds, and that improves that farmer's life. If they can get a call that tells them something is wrong right now and they can go adjust that right now in real time and not find the problem a half a day later when it was an issue several hours earlier on, is going to be important. And it develops our capacity to better understand what that bird's behavior is telling us, how they act, what are they telling us, sound levels, their movements. All of that stuff can tell us things from a welfare standpoint if we know how to manage it. And technology is a tool, and that grower's individual management practices is going to determine whether that tool is useful or not. So improving animal welfare is a direct road towards sustainable poultry production systems. If we do not have good bird welfare, we are not going to have good production. We are not going to have good profits. Welfare has to come before profits. Current situation today, demand for chicken meat continues to grow, and there's a reason for that. We can produce chicken cheaper than we can produce beef or pork. They're smaller, they don't take up as much space, they don't use as much, they don't eat as much feed. But increasing flock size and trying to reduce the amount of labor inside the house and trying to produce our production cost can negatively impact animal welfare and behavior of those chickens, again, if our management is not what it needs to be, when it needs to be there. PLF technologies can help reduce those costs by, again, monitoring that environment in real time and giving us information on animal welfare, animal behavior, and the performance of those birds. It's non-invasive, it minimizes bird stress. It does involve both mechanical, which can be sensors and robots, and digital, which is more along the lines of computer systems and software tools, along with education, technology, and adoption. Farmers are not going to know how to manage this stuff. They're going to have to be trained, and that is where we come in. We're going to have to give them the tools to work with, and we're going to have to teach them how to use it because they're not going to know how to do that. PLF systems usually are set up in 3 different levels. We have data collection, we have the processing of that data, and then we have the supervision and control of what we do with that data. Now, there are numerous precision tools out there that are available for data collection. Sensors, cameras, microphones, Internet of Things, algorithms, artificial intelligence. Combined, all of these things support multiple areas of poultry production. This includes the environmental conditions inside the house. This includes how those animals behave, the health, the welfare, and yes, even the production efficiency and how well those birds perform. Information perception is a little bit different when you look at PLF technologies because we do have today all of these things we just talked about, cameras, microphones, Wi-Fi, all of these information collection things that assess what's going on with those chickens, that assess what kind of environment is going on inside that house. So we can collect the information. We can also process that information. There's models, there's algorithms that have been developed by different types of software that will allow us to take action and control the activities based on what that information is telling us. So again, applications, interfaces developed by computer systems can talk to the individual buildings, can talk to individual farms that may not even be on the same site, and create databases and platforms that can send information to the farmer that can tell the farmer, you've got a problem here, you need to go check on this now. Commercial poultry production is a very complicated structure in how it is put together. Commercial poultry farming is not an easy thing to do, and it's not simple. It hinges on how well that grower manages a whole series of other things. The performance of those chickens, the kind of genetics that those birds are. Different genetics require different management on the part of that grower, the health of those birds, the nutrition of those birds. And then when those birds go to processing, every production system must be understood quantitatively. Poultry production is very multifactorial. We've got live animals that we're dealing with, and it's essential to establish correlations between the different types of data. And these correlations must follow practical animal science principles and statistical accuracy if we're going to be able to get any value from it. You know, non-correlational data doesn't do us much good because it slows down the long-term sustainable growth of where we're trying to go. And each individual chicken in that house, each animal is a unique biological system that adds multifactorial complexity to the overall production system. And if you've got 40, 50,000 birds in a house, you have a lot of multifactorial complexity you're going to have to deal with. Again, hopefully the objective is that we have quantitative information on any indicator, whether it's the environment, whether it's what's going on inside that chicken house, but this information should be available to the right people at the right time, at any time. And again, if we can monitor this stuff in real time, we can go a long way to being able to do that. Again, it's going to require the development of a PLF platform, and we're going to have to optimize the things to give us what we want, the outcomes that we're looking for. And that can be decision making based on quantitatively optimized information using artificial intelligence, but also improved information recording, ensuring that we can track data, that we can look back and see where it's coming from, when something happened, why it happened, and try to avoid these things from happening in the future, and identify recurring production patterns through mathematical techniques. Again, though, there are a lot of obstacles to applying PLF technologies inside a chicken house. The lack of technology validation is one of them. A lot of these items that are out there are still in the experimental stage. They're not quite ready to be put in a chicken house yet. And we'll talk about that a little bit more here in a little bit. But even though there are a lot of things in the pipeline, that doesn't mean they're ready to go right now. And limited capacities in the case of large flocks with many small bodies. Again, if we're wanting to track individual data, and we've got 40,000 birds in a chicken house, how do we track individual data? Yes, it's easier to track flock data overall than it is individual data. But if we want data on individual chickens, how do we go about that? And again, getting that type of technology that can do that is not going to be cheap. The high investment cost of the devices, whether it's robots, whether it's RFID systems, again, individual chicken farmers are not going to be able to pay for this technology on their own. Again, we're going to have to get the integrators on board because they are going to have to help with the cost of this. We're going to have to show them there's advantages to their bottom line to use this type of technology, because we can't convince the farmers alone and expect to get a lot of these systems inside a chicken house. Again, a lot of the farmers that use this stuff are not going to know how to use this stuff. The farmers, the caretakers, a lot of folks today that grow chickens, English is not their first language. It may not even be their second language. So language barriers exist that we're going to have to work around all of these things. And again, farmers can usually change a fan motor out that burns out. They can do that on their own. They can change a feedline motor out if it burns out. They're capable of doing that. There's a lot of things in a chicken house farmers can fix. They can fix a busted water line. There are a lot of things that they can do, but on this high-tech technology type stuff, they're not going to know how to fix that equipment. If it breaks down, there's going to have to be a technical specialist somewhere that can be called to repair the technology. So the folks that actually can fix something when something goes wrong right now are few and far between. And that's going to be another obstacle we're going to have to figure out how to get around. And then the specificity of tasks of different devices. Some units can do some things, but not do something else. So again, we may have to have multiple pieces of equipment to do multiple things that we want done. Is there harm to welfare from PLF? Again, it's based on how we're going to use that stuff. The greatest adoption of PLF technologies right now has been in intensive animal type production systems. But there is a risk that this technology may be used again to intensify production with little emphasis placed on enhancing the animal welfare of the flock and making things better for them by promoting positive experiences for the animals. And again, as we've already heard earlier this morning, less farmer and less animal contact is something that the poultry industry worries about. For the most part, most chicken growers or most chicken integrators already think that their growers don't spend enough time in the chicken house. And again, integrators fear that the more automated things become associated with what PLF technologies can do, may further lessen the human animal contact and decrease the opportunities for the grower to directly observe the health and the well-being of the birds that are in their care. And farmers, again, may become over-reliant on PLF technology if they get this and they expect the technology to isolate the problem and fix things, and they may not be as observant as what they normally would be. We've already heard that earlier today from Janice and Marion, and those things are real-world issues that we're going to have to deal with as we develop more and more PLF technology inside the chicken house. Again, right now, there is no substitute for that farmer being in the chicken house. And the integrators are well aware of this, and they want to see their growers in the chicken house. Yes, PLF technologies can certainly be a help and a benefit, but the growers need to be in the chicken house. And farmers are going to have to be trained on the techniques to best utilize PLF technology before it's actually installed on their farm. Someone is going to have to train these folks how this equipment needs to be used. If they don't know how to use it, and it's not going to be their fault they don't know how to use it, but if they don't know how to use it, what they do or what they don't do will likely not be applied in the best way that can maximize benefits for all the animals and for the farm itself. In general, farmers do not understand very many PLF technology systems today. There's a lot they do know, and they're good at what they do, but PLF technology is new, it's high-tech, it's sophisticated, and in most cases, farmers do not understand this system. That's not to say they can't be trained to manage it and learn how to use it, but someone is going to have to help them. PLF systems are basically tools to assist farmers to be better managers. They're not replacements for those farmers in the chicken house. And everyone's going to have to understand this. The people that sell the technology, the farmers themselves, and the integrators are all going to have to understand that these things are tools. They're not replacements for the farmer or the grower inside the chicken house. Some of the barriers to artificial intelligence adoption: algorithms developed in the lab are not commercially available out there in the chicken house. And again, these algorithms that are trained in the lab, that's not going to be very valuable in the chicken house because it's a different environment. There's going to have to be algorithms that are trained and validated in the chicken house, not in a controlled research environmental lab somewhere, because the two are two completely different things. And farms differ in the structure and the management of how those houses are designed. The layout of the poultry house, where the equipment is, the stocking density, the litter material that is in use. All of these things encourage occlusion. They encourage shadows. There's noise impacting the audio recordings, fan motors running, feed line motors running, and there's confusing backgrounds that affect camera images. We'll talk a little bit more about this later when we get into some of the UT research that we've done. But these things are going to have to be worked around and they're going to have to be addressed. And the algorithms are going to have to be trained to each unique environment. And there's no one doing that right now, especially at the chicken house level. The number of images that it takes to train these algorithms for on-farm monitoring are too time consuming to be practical on the chicken farm right now. But we're going to have to be able to address that in the future. PLF is the use of technology to automatically monitor livestock and their environment in real time. And again, it's this real time that is where the great advantage is. It does aid in farm management. It supplies the farmer with relevant information on which to make management decisions. It does require precise control, but this precise control can improve production and profitability. Again, if we keep the chickens within those very narrow limits of where everything is ideal, we will see improved production and profitability, and we can also improve animal welfare at the same time. But again, is there too much emphasis on production and profitability? Do we look at it first and animal welfare second? Have we got the cart before the horse? So we're going to have to decide how animal welfare fits into all of this. And PLF technologies do have the potential to improve animal welfare because, again, it is non-intrusive. It is continuous monitoring versus a snapshot in time. And that's going to be extremely important too. The continuous monitoring, knowing what's going on at any particular time is going to be invaluable. Faster reaction time and quicker interventions are going to mean that we're not going to have as many issues as what we would otherwise. And greater welfare objectivity assessments are possible with PLF technology than what it is with human observers just in the chicken house every now and then. But again, the fear among some is that PLF will be used as a substitute for addressing the factors that actually do make animal welfare better for the flock. PLF is only a part of improving animal welfare. There's all of these other things we have to consider as well. PLF technologies will provide added value, especially regarding improved welfare and reduced environmental impact and long-term sustainability of the poultry industry if we use it correctly. However, an economic investment is going to be required on somebody's part to get this equipment and install it and use it correctly, demonstrating and verifying to the commercial poultry industry that there are economical, there are welfare, there are environmental advantages to using this technology, both in the medium and the long term, are going to be critical if we're going to sell these folks on this technology. PLF farming is a little bit unique though, because poultry farming is a little bit unique because PLF is aimed at better welfare or increased production. Again, that decision has to be made up front. Improving welfare in broiler farming is a major focus due to the sheer number of birds that are in these houses. Again, when you have 40, 50,000 birds in a house, that's a lot of living creatures to be responsible for. PLF technology can improve the poultry welfare environment, but again, we need to look at some of the challenges and some of the opportunities that are out there. So let's look at some of the University of Tennessee field testing. We did field test a PLF robotic system in a commercial broiler house in Tennessee. The gentleman in the picture is Tanner Thornton. Tanner done his master's thesis on this experiment. I was on Tanner's master's committee. I was not his major professor. Tanner is currently my PhD student, but Tanner done his master's thesis on this type of technology. We had it in a commercial farm. The robot rode on a rail that was mounted to the ceiling, and it could move through the house at staged times and collect data on temperature, relative humidity, the ammonia level in the house, the CO2 level in the house, the airspeed that was going on inside the house, depending on whether the fans were running or not, what the light intensity was, what the sound intensity was. It had the ability to collect a lot of data. It also had the ability to detect and locate mortalities. bad droppings inside the house, and wet spots on the floor using a proprietary vision analysis system and thermal cameras mounted on the bottom and the sides of the camera. Now, at the end of the day, it gave everybody a report on what it had collected in the previous 24 hours. It sent them an email with this report on it. That's a lot of data, folks, to be getting every single day on what happened in the previous 24 hours. But that data is there. It's available on the temperature, on the air quality, on the welfare, where the dead birds were that the unit was finding. It's a lot of data to look at. And again, there's a risk of too much information that the farmer is not going to use. It needs to be condensed and it needs to be integrated into that house controller where the farmer can glance at the controller, and that's what they do today. They glance at the controller when they go in first thing in the morning. What's the temperature? What's the ammonia level? And they move on. They go into the house and they begin to do whatever they need to do. But if they have to spend too much time trying to assess all of this data, it may be more than what they want to deal with. It may overwhelm them. And that's one of the things about, having access to all this data that we already talked about earlier today. Yes, we can have access to it, but how are we going to use it? And how much time are we going to try to spend trying to figure out how to use it? Some things the PLF robot did very well. Other things it did not do so well. When comparing temperature and humidity data, the robot sensor at robot height and at bird level were two different environments. The temperature was significantly lower and the relative humidity was significantly higher at bird level than it was at the robot sensor height. Again, the robot was suspended from a rail from the ceiling. So the robot sensors were, 5 feet off the floor, and the chickens are on the floor. And we saw a distinct difference between the temperature that was at robot level and the temperature that was at bird level. So the robot data, depending on how it is set up and where you have your sensors, it may collect data that is not accurately reflecting, what the chickens are experiencing, what their welfare environment is down on the floor. Mortality detection was one of the main things that the company that made the robot wanted to focus on, that it could find the dead birds in a chicken house and send a message to the grower when it sent its report that it knew where the chickens were. But mortality detection rate was in a real world situation was very low at 31%. We had a lot of false positives. We had a lot of double counts on the same dead bird being counted multiple times. The detection rate was better for the bottom camera that was aimed straight down directly at the floor underneath the rail than what it was on the two side-mounted cameras. Detection rate was better when the mortalities were also put into an enclosure. If we put them in a box, if we put them in a clear situation that kept other birds from commingling around the dead bird, it did a whole lot better at finding mortalities than it did if the birds were outside of an enclosure and other birds around that dead bird kind of confused the system. Detection rate at the feed lines and the water lines and at the sidewalls of the house was really very, very poor. Even within an enclosure, it only found 4 to 5%. Outside of an enclosure, if it was near the feed lines or the water lines or the wall, it only found 0 to 1%. Feed lines and water lines and areas that are near the walls are high concentration bird areas. Where there's a lot of birds concentrated, it made it very difficult for the cameras to locate just exactly where the mortalities were, and if that was an actual live bird or an actual dead bird. The field of vision for the side cameras was really not very good. It could not go out very far from the unit itself and distinguish what was going on. Also, broiler houses, the light levels are dimmed down throughout the life of the flock after the birds get to be about 10 days, 2 weeks old. Low light level inside the house also prevented the cameras from finding any staged mortalities that we would specifically put in one place or another to see if it could actually find that dead bird. Even the design of how the robot was put together made it difficult in some cases for the camera to actually find where the robot was. So if we look at this picture here, we see in the front at the bottom of the picture is the feed line. And there naturally there's a lot of birds concentrated around the feed line, but it was able to find the dead bird in that pink rectangular box. It knew that bird was a dead bird and not a live bird. We staged that live bird or that dead bird right there. Tanner also staged all of those other dead birds where those yellow arrows are pointing at. He lined them up across the house to try to see whether the camera could actually distinguish a live bird from a dead bird. It could find that one right there by the feed line, which was not very far from the camera, but has the dead birds and the camera got farther and farther apart, it was not able to find those. Even though those are dead birds, it did not recognize that, yes, that is a dead bird. Part of that is because those other chickens, those live birds, are also nearby, and that complicates that camera being able to try to figure out just exactly what it's seeing. Again, if it was directly under the robot, it did a whole lot better job than what it could if it was between the feed and the water lines, or if it was over by the house sidewall. Again, inside the pen, directly under the camera, it could find almost 60% of them, but it could not get anywhere close to that kind of accuracy when we got over by the feed lines or when we got over by the sidewall of the house. So there are opportunities. Vision detection system on this unit was affected by occlusion. It was also affected by the presence of other birds, house infrastructure, the distance to the mortality from the cameras. So again, there's opportunities to fix these problems. Again, in these two pictures here, what you see down at the bottom, that curlicue thing, that's part of the cabling on the unit, on the robot itself. And it confused the camera in picture A, it confused the camera into thinking that that pink bird inside that box is a dead bird, but that bird is standing up and is perfectly alive. That bird is not a dead bird, but the camera thought that it was. But these things can be fixed. Again, the technology is not where it needs to be inside a chicken house for a lot of these things just yet, but that's something that's fixable. With field testing and with some work, those things can be fixed. So PLF technology can meet challenges faced by broiler farms today. It can monitor the conditions in big houses with bunches of birds and with little labor. But again, are we going to use it to focus on bird welfare, or are we going to use it to try to improve production efficiency? Because the two things are different things. And chicken house environments are very, very harsh. There is a lot of dust, a lot of ammonia, a lot of moisture, all of these things that technology does not like. So again, the technology is going to have to be field tested because it's a totally different lab or a totally different environment than a clean research lab somewhere. And data at robot height is going to be different than data at bird levels. We're going to have to figure out how to account for that. It's not going to do us any good to measure conditions at robot height if the birds are on the floor, because that's two different environments. And the occlusion by live birds, if too many live birds are close to a dead bird, it's not going to be able to figure out which birds are alive and which birds are dead. But in time, I think those things can be figured out, and mortality detection rate can be improved. It's just going to take some time. A lot of these systems are just not quite ready to go in a chicken house yet. But again, it can be done. Animal welfare is very complex and very multidimensional. If it was easy, we would have fixed all the problems a long time ago. But it's not going to be easy to fix. But it can be fixed. It's just going to take some time and some effort. and some work by these folks that understand this technology. Again, these technologies are tools to assist the farmer in managing the animals and addressing animal welfare, but it cannot replace the farmer in the chicken house. They are still going to have to be a major player. PLF technologies do have the potential to improve farm animal welfare, but again, it's got to be used correctly. And that's where management comes in. The danger and the benefit both lies in how the PLF technology is going to be used in the future and what it is used for. Again, are we going to focus on animal welfare improvements, or are we going to focus on increased profits, hoping that animal welfare tags along for the ride? PLF systems may increase animal welfare if the farmer responds to the alerts that are sounded, but again, that's up to the farmer. Management's going to determine the value of how well this system works. Good tools are not necessarily a guarantee of good results, especially if those tools are mishandled or they're not used correctly. So to kind of summarize all this, PLF technologies are a glimpse into the future of livestock production going forward. Many technologies are still in the experimental stage and are not quite ready for the chicken house yet, because there is a huge difference between the lab and the chicken house. And we're going to have to be aware that the integrators already worry that growers don't spend enough time in the chicken house. They certainly don't want them spending any less time if they've got all this extra high-tech technology. And growers are worried about how best to use that technology. Someone's going to have to train these growers because they are not going to understand most PLF systems. And there are concerns on whether the PLF systems will be used for better animal welfare or just to increase profit margins. But PLF technologies do have vast potential to improve animal welfare and improve flock health. But again, there's still a lot of questions to answer. It is a powerful tool, but again, it must be managed correctly. And again, that's going to be up to the growers and up to the integrators as to what they want to focus on. These are my references. With that, I'll say thank you. I'll try to answer any questions anybody might have.
Thank you very much, Dr. Tabler, for a really fantastic talk with really great practical considerations in this area. We do have a couple questions. But first, I want to remind all of our audience, if you could help us out by giving us some feedback on the symposium that will help shape future symposiums. I've posted the link to that survey in the chat box. So first question, what welfare metrics do you think producers would like to detect with PLF technology? You had a bunch of metrics at the beginning of your talk. Do you think there's any priority for particular measures?
Well, within the broiler industry, there's a whole lot more focus today on things like gate score, on things like foot pad score. Again, those things that we haven't focused on a whole lot in the past, I think are going to dictate where we are going forward. Again, foot pads are important because of a reason. There's a market for paws. We don't eat many paws in this country, but they are a huge profit margin for chicken companies. And again, they see that. And again, there's a lot more emphasis focused on foot pad dermatitis today than there ever was when I first started in the chicken industry. So again, things like gate scores, things like foot pad dermatitis, again, how those birds interact with each other, especially if we can get some technology that is reliable, that does use cameras, that does use microphones to see how those chickens actually behave when we're not in the chicken house, I think are things that are going to be things we're going to pay more attention to in the future than what we have in the past.
Great. So you mentioned that PLF is really expensive. Do you know, is anyone thinking about potential opportunities for financial support, either government subsidies? So for instance, in the UK, farmers get government subsidies for having things like hedgerows, or plant regions at the edge of their fields. Do you think any thoughts about that?
I don't think there's enough emphasis on that right now. I think, again, because it is expensive, again, I think we are going to have to get the integrators on board and not just sell the farmers on it. If we convince integrators that yes, if your growers will utilize this technology and make them a better grower, and we see better production, decreased feed conversion, increased livability. If they can see that this technology offers them, profit margins, I think there will be interest from the integrators to cost share some of this stuff with growers. Things like that have been done in the past. If they wanted a grower to add more fans or put in a cool cell system if they did not have a cool cell system, and they're willing to work with these growers and cost share this and do it over a number of flocks where they hold out a certain amount of that grower's, chicken check to help offset some of the cost of this. I think we're going to have to get the integrators on board, and they're going to have to see an increase in their bottom line to make them interested in this stuff. And again, I think farmers will be interested in it to some degree once they understand what's going on. But again, them by themselves are not going to be able to pay for this until the cost of this technology comes down. Now, 10 years from now, 20 years from now, it may be a whole different ball game because again, it will be more common, it will be more practical, and again, as more and more systems get in place, the price will come down. But right now, when it's new, when it's high tech, it's going to be expensive, and growers by themselves will not be able to cover all the costs of that. We need to get the integrators involved to help. Whether the government is going to be involved in that, I'm not the right person to say on that. I just like to get the integrators convinced that there's value in this.
Sure. I think we have time for one more question. Um, as we've heard today, PLF and different technologies are sort of a dime a dozen coming out in publications, and new things are being created all the time. But from a production standpoint, what advice would you give to engineers who are building these technologies?
Well, the first thing is these folks need to understand what goes on in a chicken house. Again, whether they need to have a tour of one and understand, what kind of humidity levels, dust levels, ammonia levels, CO2 levels, the things that make an environment harsh. The folks that do the design and need to know what the folks that are going to use this technology are going to have to be up against. So the first thing that they need to know is just exactly what kind of environment they're going to put their high-tech equipment into. Otherwise, they're not going to know what that farmer in the field is going to have to deal with and be up against. And they're not going to know if they design it in a lab and it spends all its time in a lab, they're never going to know whether it will perform in a harsh environment like a chicken house. So the first things the designers and the engineers need to do, in my opinion, is spend a little bit of time in a chicken house.
Great. Well, thank you very much once again for your fantastic talk. And with that, I will turn it over to Marissa for closing out the symposium.
Awesome. Thank you, Richard. Thank you so much to our wonderful speakers, Dr. Marion Dawkins, Dr. Janice Sickford, and Dr. Tom Tabler. I certainly learned a lot about the different technologies that are available, some of the constraints, and then, of course, practical implications as well. So thank you so much. And thank you to everyone who joined us today. We will be posting the recordings on our PEC website and our YouTube channel as well. And then in case you've forgotten, which you probably haven't, we do have a survey link in the chat, and we really do appreciate your feedback. This is how we